All right, so chapter 5 is on wave motions and sound. All right, so the importance of studying waves is so that we can kind of understand the environment around us, maybe try to give people advanced warning about natural disasters that involve waves, such as earthquakes and tsunamis. So if you guys remember, 2004, there was a tsunami in the Indian Ocean. 200,000 people, passed away from that event. Millions of people were displaced from their homes. There was billions of dollars in property damage loss. All right, so studying waves are important. All right, so some of the basic definitions that you need to know with forces and vibrations. All right, so our vibration is just a back and forth motion that repeats itself. All right, so if you think about like a pendulum that swings back and forth, that is a vibration of back and forth motion. All right, so a motion that repeats itself is called periodic motion. And when an object has not been disturbed and it's at rest, it's said to be in equilibrium position. Equilibrium just means it's in balance. And then a complete vibration is called a cycle. All right, so period is denoted by capital letter T, and it's the number of seconds per cycle. So it's the time frame per cycle. So the length of time it takes for one cycle of periodic motion to complete itself. All right, frequency is denoted by lowercase f, and it's how fast the oscillation is occurring. So it's the number of cycles per second. All right, so the frequency is inversely related to the period. And the unit of the frequency is the hertz, where hertz is equal to seconds to the -1 power. So here in the top corner, that is your equation for frequency. So make sure that's on your cheat sheet for future homework purposes, tests, and quizzes. Like I said, I'm not going to make you guys memorize these equations. Just go ahead and write them down on a sheet of paper so you'll have them when you need them. So frequency is equal to 1 divided by the time period. All right, so there's different types of waves. You have longitudinal waves, and then you have transverse waves. So a longitudinal wave, this is when a disturbance causes the particles to move closer together or further apart in the same direction that the wave is moving in. All right, so everything is moving in the same direction. Transverse is the opposite. So the disturbance that causes the motion is perpendicular to the direction of the wave. All right, and then the wavelength is just the measured distance between two crests or two troughs. The speed of a wave, that is denoted by V, which is your wavelength times your frequency. So this lambda signal right here, this is the wavelength in meters. Lowercase f is the frequency, and seconds to the -1 power, or hertz. And your speed, again, is in meters per second, because that's the distance traveled over the time frame that it took to travel that distance. All right, so let me go to the whiteboard. Okay, so let's just say a wave is, an up and down motion. This is your isolated motion. All right, so your lower points, these are called troughs. Trough. All right, your peaks are called crests. So this is a crest. This is a crest. All right, so the distance between either two crests or two troughs is known as your wavelength. So lambda is your wavelength. All right, so the distance between two peaks or two low points is your wavelength. So this is the lambda, Greek letter, lambda signal, Greek symbol, and it is your wavelength. Wavelength is usually measured in meters. All right, so your peaks are your crests, The distance between two crests is one wavelength, and your deep wave parts are your troughs, right? The distance between two troughs are also a wavelength. All right, so the distance from crest to crest or trough to trough is the same across a similar wavelength. All right, so your speed of a wave, or how fast a wave is traveling, is the wavelength, right? Lambda times f, which is our frequency in hertz, or seconds to the -1 power. All right, amplitude is how far the wave is from its maximum displacement. So it's the high and the low of the wave. So if we go back to the whiteboard, our amplitude would be between this crest and this trough. All right, so the peak down to the lowest point would be our amplitude A. All right, so it's the peak, the distance between the peak and the trough. So that's the amplitude. Wavelength is from crest to crest or trough to trough, and amplitude is from peak to low point. All right, so high energy waves are going to have a higher amplitude, and low energy waves are going to have a lower amplitude. All right, now for sound waves. So sound comes from our vibrations that occur within instruments. So here we have different instruments. You got your piano, your guitar, your horn, your flute, your violin. All right, so loudness of sound is subjective from person to person. What I consider loud may be different from what you consider loud. Okay, so also if we're at a concert and you got front row seats and I'm all the way in the back, right? Your distance to the speaker is shorter than my distance to the speaker. So the sound, the loudness of the sound may be different for me than for you. All right, so loudness is related to the energy of the vibrating object, and it's the condition of the air of the sound that the sound wave is traveling through. So whether the sound wave is traveling through air or water, and 3, the distance between you and the vibrating source. Okay, so the closer you are to the source, the louder it's going to be, the louder the sound is going to be. All right, so pitch, it rises when the frequency rises. All right, so the sound is higher as a result. And when the pitch is lower, then the frequency is also lowered. So it makes the sound lower as well. All right, so we're going to work out a couple problems. So for number 1, a vibrating system has a period of 0.5 seconds. What is the frequency in hertz? So if we were to scroll back up to the top, we'll see that frequency is equal to 1 divided by the time period t. All right. All right, so number 1 asks about the frequency. Frequency is 1 divided by the time period. So let's go back and see what our knowns and unknowns are. All right, so we're asked to find the frequency, so that's our unknown. And then the period of the vibration system is 0.5 seconds. So frequency is the unknown variable. So put a question mark by there. Our time period is 0.5 seconds. So what we're gonna do is just plug in what we have. All right, so 1 divided by 0.5 is actually 2. All right, so this is gonna be seconds to the -1 power because it's in the denominator, or the SI units can also be written as hertz. All right, let's go to number 2. A sound wave with a frequency of 260 hertz has a wavelength of 1.27 meters. With what speed would you expect this sound wave to move? So we're looking for our speed, which is v. We have our distance, and we have our frequency. All right, so let's write down what we have. All right, so if we go back up into the problems, we'll see that the speed of a wave is v is equal to lambda, which is a wavelength, times the frequency. All right, so v is equal to lambda, which is our wavelength, times the frequency. So we just plug in what we have. They told us the wavelength was, let me scroll back down. The wavelength was 1.27 meters. So 1.27 m multiplied times the frequency, which they told us the frequency was 260 hertz. Hertz or seconds to the minus 1 power. So 260 hertz or to seconds to the minus 1 power. All right, so it'll be meters over seconds. All right, that's the SI unit for speed. With the benefits of music, which are sound waves, they improve the mood, they reduce stress, they lessen anxiety, it improves exercise and memory. All right, it eases pain, provides comfort, improves cognition, helps people or children that have autism. So if we go back up to the frequency equation, which is frequency is equal to 1 divided by the time period. Now let's go back to the whiteboard. Okay, so number 3, we're switching it around. Instead of solving for frequency, we're going to solve for the time period. All right, that's the unknown. So we're going to use the frequency equation. I said the frequency was 14.5 hertz or seconds to the minus 1 power. All right, so if we use the same equation, 1 over t, and we solve for t, to get it to the other side of the equation, we would have to multiply both sides by t. And then to get t by itself, we would need to divide by our frequency f. All right, so the t's cancel out on the right-hand side, the frequency cancels out on the left-hand side. So we're left with our time period being equal to 1 divided by the frequency. So we're going to plug in 1 divided by 14.5. I rounded mine up, so it's 0.07 for me because it was an 8 after 6. So I just went ahead and rounded up. All right, don't forget that our time is in what SI unit? All right, so here, our period T is the number of seconds, right? So the period for the time period of the cycle is going to be in seconds. All right, for hertz, it's seconds to the minus 1 power for hertz for frequency. But for the time period, it's just seconds.